Cool. Yeah, talking about some multi-dimensional climate data on the web. Some of you maybe seen a similar talk I gave at SAT Camp here, but yeah, I'm at Carbon Plan, and we do open science and open data, and we have a cool web page for slides like this with lots of cool animations. So I always got to put it in the slides. Um, so. We love Czar because it has this multi-dimensional capability and a really nice access pattern. Many of you also love Czar for similar reasons. Our climate data often ends up in a shape that really takes advantage of this. And it also lends itself to shaping it in a way that gets it onto a web map. And so the way that we do that is with a tool we've developed called ND Pyramid. And this reprojects user our data into Web Mercator to make it happy on the web. And it also builds overviews and pyramids. So we kind of output ends up being this thing on the right, which if you've ever poked around a tile set directory for like a web map, it's a similar hierarchy. And so the output of that is a bunch of chunking that lets us access data in a map tiley kind of way. And then this has also been around for a while, and lots of folks have worked on it. But Carbon Plan Maps lets us visualize this in a web map. And so this is a typical kind of shape of what you would see. This raster component is what does the real lift of getting that ZAR data onto a map. And the underlying map libraries, Mapbox.gl, so you can have all your base maps and things like that. But we've got this ZAR layer that's kind of sandwiched onto it. And that lets us get that data onto the map nicely. And so you can get a web map and zoom around and slide through time, things like that. Um, but what I'm excited about showing you today is our latest take on using this tooling to make a cool map that I'm pretty proud of. And this came out last year. We have an update to it with some new data coming out hopefully pretty soon here. But this was for a data set of alkalinity enhancement. So this is a form of carbon removal. I'll just scroll through here and give you a sense of the science here a little bit briefly. So in the ocean, you've got carbon exchanging with the atmosphere in the ocean here. But in the ocean, there's also carbonate chemistry going on. And so there's these non-CO2 forms of carbon that are the bulk of how that carbon is stored. If you add a bit of alkalinity to the ocean water, the idea is that that actually shifts this chemistry to allow to kind of push this into this non-CO2 direction of the equilibrium. And so that opens up kind of a void or some space for more CO2 to come out of the atmosphere into the ocean and then be stored relatively permanently in those non-CO2 carbon forms. This works better and worse in different parts of the ocean. So depending on many different ocean characteristics, so like wind helps that CO2 exchange rate happen. Ocean currents can move things around to different places with different wind regimes. And then there's the ocean's movement itself. So if your alkalinity that you added to the surface ocean dives and it's not talking to the atmosphere anymore, you're not going to pull down any more carbon. So spatially, this is a really interesting thing to map. And so Carbon Plan collaborated with Seaworthy, and Seaworthy drove this modeling effort. They're the ocean experts, and so modeled tons of different locations across the ocean, 690 of them, and that resulted in a bunch of data, so 15 years worth of data at monthly resolution for four different injection seasons. So different seasonality was uh, accounted for there, and a bunch of different variables, and it comes out to a big old ZAR store. And so, how do we get this half a terabyte of ZAR on a performant web map is our challenge. So that raster component for this is a little more complicated. We have a bunch of selectors here. We're grabbing a different polygon. We're choosing one of those seasons. We have a year, we have a month, and then our data that we're actually going to map here. And so we do two things. We can do a little bit of math and derive that delta value and also show the overall values in the ocean. So this slices that half a terabyte down to many different 150 or so kilobyte map tiles, which is something you can actually get on the web and fly around on your phone and things like that. So, all right, now the fun part, a little demo of the actual map itself. So this view, when you come into it, is just kind of an overview of the efficiency of each polygon kind of derived. So this chart and is driving this coloring as well. So these are all kind of coupled. So this data comes down in a ZAR. It's not spatial, so we just apply it to these vectors. The actual like spatial ZAR that's maybe more interesting to some of you folks is once you click a region. So if I just select a region here, we'll actually start to see the data associated, this model simulation associated with that region. So we're going to view it as a kind of a plume, and we can slide through time. And we had to think about our chunking here pretty carefully in order to get our performance for this slider to work through the years, as opposed to maybe like the more default chunking you might have is like you put all the months in one chunk, right? But that we wanted all of the years, the interesting plume motion is through the year. And so we have all of January for every year in one chunk. So we can just slide back and forth. And if we were to change to February, that goes and grabs a new chunk, and now we're sliding through February time. So that was an interesting little problem to solve. Can switch between our different injection seasons, switch between a bunch of different variables. A lot of them look kind of similar. They're just following that plume around. We can toggle to the total values instead of just that delta. And we can also, since we have the actual ZAR data in the browser, we can query it with a little picker here and make a time series of that region that we're interested in the ocean, download that data right in the browser. So that's pretty nice. Can also do some math on the shader code to like get a log scale version going. And yeah, so lots going on there. And lots to explore. There's 690 different polygons, so no, I don't think anyone has viewed all of them yet. So yeah, this is out. You can read the explainer. It's really well written by colleagues at Carbon Plan and Seaworthy. The tool is fun to play around with, and yeah, Carbon Plan Maps is up on GitHub. But there's also other cool new ways to do this kind of thing. Development Seed has T-Tiler, which is great. I've heard rumor of some other cool ZAR web things coming down the pipeline soon. ZARGL is a new one came out a couple of months ago. It's pretty early in development, but is really promising. I think it's a really cool take on a way to get ZAR on a Map Libre or Mapbox map. And yeah, Flux just came out. Congrats on the release. So yeah, that's what I've got. Slides are up here if you want some of those links. But thanks for the time. Hopefully I was under